In this video, I'll be covering the two tools you'll be using to create most of your larger geometry or most of the base geometry you'll work with. These are the boundary surface and the filled surface, and typically you'll be using a set of these other tools to trim those as well as modify them for final production or final models. But these tools are the tools we're going to find the most useful: boundary and filled surface, especially for producing complex geometry. I'll later speak about the lofted surface a little bit, but the boundary covers pretty much everything the lofted can do and generally does it better. So we'll be using, as I said, these two tools. In the intro to surfacing video that I did for this section, I didn't really discuss the back end for more complex surfaces. SOLIDWORKS uses something called NURBS surfacing, which is non-uniform rational basis spline. I'm not going to go into too much detail on this. Really what you need to know is that SOLIDWORKS is always trying to produce a four-sided surface like the one you see here, or the one you see here. And I'll show using the face curves that SOLIDWORKS is creating essentially the surface with a set of splines and control polygons. And these are roughly perpendicular to each other, and everything that you see that's not four-sided is typically going to be trimmed away for anything non-algebraic. So I'll show an example really quickly here. So something using the three-point arc tool, for example. If I create an extruded surface, and then grab an edge, you'll see a radius, which indicates that this is indeed a single equation or single algebraic expression. So for anything that can be modeled using a simple algebraic expression, it won't be using the NURBS surfacing. For everything else, if I create another surface here, I'll just go ahead and drag off a plane and add a spline in. And create a boundary surface. So here I have a four-sided surface. I can see I still have that radius at the end since this is represented by a single equation. Whereas the spline, you simply get the arc length because it is changing continuously throughout. And if you want to know more about NURBS surfacing, just look it up on Wikipedia. I won't go into too much detail as it's not really that necessary to explain anything further than what I've said. The most important thing here is how SOLIDWORKS produces the surface and what limitations it creates as a result. So you can see I added in face curves, and you can see that this is made up of a series of splines that are roughly perpendicular to each other. I'll talk a little bit more about this concept and its implications with the boundary surface and filled surface later on in the video, but for now I'm going to go ahead and discuss the use of the fill tool and the boundary tool. So you saw what I did with the boundary surface there. Essentially, boundary surfaces are for creating a surface within a four-sided shape, and these can be created in several ways. And for non-four-sided shapes, 2, 3, 5, 6, 7-sided shapes, we will be using the fill tool. And like I said, I'll show the difference in the final part of this video. But to start, I'm going to go ahead and show two sketches in this selection manager folder. And I have two sketches, you can see, with two sets of splines in each. And just like the loft tool, there's a selection manager we can use for the boundary surface tool. In this case, if I just select a single spline, it's going to bring up the selection manager because I have multiple entities in the same sketch. And I can simply just choose these two out. With the boundary surface tool, you want to choose opposing splines or opposing entities, and then in the direction to, add your other curves in. And this functions similarly to the guide curves in the loft, but with the boundary surface, this is an exact fit, whereas with the lofted tool, the guide curves are simply a guide. So there's a little bit of an error in it following that curve. In this case, we do have an exact fit. So this is simple. This is just a flat planar surface. Typically, we'd be using the planar surface or filled to create this, but this is just to point out how to select out splines. Go ahead and hide these out. And you don't always have to have a shape bounded by those 4 splines or a fully bounded shape. If, for example, I have a cross, I can select these 2 out. And a typical mistake for people who are new with the boundary surface tool is they'll try to select out the 2 separate directions in the same selection box. And you can see even if I right click and go to flip connectors, these are just going to cross because they're crossing each other. We actually want one in a single direction and the other in direction 2. And I'm not going to go into too much detail on the options. I'll cover another video of how to use the boundary surface options and modify that. But you can also see connection points at the end of the boundary surface, and we can use these to actually trim down the surface to a different size. And if we have points to select to, we can drop that in on a specific point. Along with a cross, you can also do a T and get the same result. And the boundary surface does offer controls that you don't get in other features, such as the swept surface. So you can actually use the boundary surface tool to create essentially a swept feature. And here, if you think about how the sweep surface works, which is through a profile and path and guide curves, in this case you can simply use one of these as the profile, a path, and then if you actually have 2 other curves running in a similar direction to this, you can also use those to guide this surface. So even though the swept surface, or even though you think of swept surface when you think of dragging a surface out like that, you can use the boundary surface as well to create the same geometry. Just like the lofted tool, I can select out multiple surfaces and then choose that guide curve as the direction to. And thus far I've shown sketches that are limited to essentially the same direction. They're parallel planes. But you can also create these in an angle or any angle that you want. And then you can add in your boundary surface. So you can essentially create any series of curves at angles to each other. and then use those to create the surface that you want. The next thing we'll look at is using the fill tool. And so the limitation on the boundary surface is that it is a four-sided surface. And so if we have examples where we want to create a two-sided surface, such as this, we can use that filled surface tool. And I'll discuss this optimized surface option in a little bit, but typically we'll want to turn that off so that we can get this four-sided surface that's trimmed away to fit this boundary. One of the limitations on the filled surface is that we have these tangent and curvature options, but we need faces to reference off of. So in this case, I might have to create, if I want curvature continuity to another face, I would have to create that face first, or a reference face. Similarly, a three-sided surface should be created with the filled surface tool as well. And you can see the filled surface tool is quite a bit simpler than the boundary surface. We also have an option for constraint curves, where we can add in curves in the middle to pull the surface out or in as we want. But this tool will do most of the work for you. It won't always give you the exact result you want, so you might have to come in and create a surface using the boundary surface or one of these other tools. But when it does work, it usually works pretty well. And I have a five-sided surface as well, or five-sided boundary. And once again, this is fairly simple for the filled surface tool. And then you can go on to create six-sided, seven-sided, eight-sided surfaces, whatever you want. The likelihood is that you won't really exceed 5 or 6 at any point. You'll also want to be careful with the geometry you work with. I actually took a look at if I could create a larger number of side surface. In this case, this is about 9 sides. But the issue here is this is too complex to produce a filled surface. So if I do indeed select all of this, and for some reason I can't select this, so I'll go ahead and fix this up. I can see I have multiple sketches in the same sketch. So once again, if I tried to create the filled surface from this, the geometry will be too complex and we'll get an error message. So you'll have to trust me on this. I can't select this right now, but if I did select it out, you'd get an error message saying that it's unable to patch the boundary. And that's simply from the sharpness and complexity of the geometry. And this surface would probably overlap itself, which SOLIDWORKS doesn't want to allow to happen. If you did ever run into a case where you had to create something so complex or something very complex, it's typically easier to go in and actually create these in multiple sections. So if, for example, I use the boundary surface tool, I can select out just 3 of these entities and then continue to create surfaces from there. So if you do have multiple surfaces or a very complex boundary that you need to create, you can create this in multiple surfaces. The last thing I'll talk about in this video is singularities and the reason why you can't use a boundary surface for a 2-sided or 3-sided surface or larger, and why you can only use it for a 4-sided surface. So the boundary surface tool itself is quite powerful. One of the nice things about this is we don't need extra geometry to make this normal to profile. But the issue that we run into is that SOLIDWORKS is trying to put a 4-sided surface into a 2-sided boundary. And the result of that is a singularity at both corners. And if I had a 3-sided surface, I'd have a singularity at a single corner. And typically this will look fine. You'll get a pretty smooth surface. It may even be curvature continuous at the ends. But SOLIDWORKS will actually have trouble working with this geometry when we produce a solid. So for example, if I thicken this, sometimes this will fail. In this case it doesn't, but what it does produce are these artifacts at the ends coming off of that point, because it doesn't really know what to do with itself at this corner. If I look at the face curves on this surface, you can see just like it looked like in the boundary surface, it's all just coming into that point, so it doesn't really know what to do with that geometry. What we want is the surface to be overbuilt and then trimmed down. Effectively, we always want what would be an infinite surface that's simply trimmed. SOLIDWORKS deals best with those. For example, if we had a fillet on these ends, typically with the boundary surface that'll still be going down to a point, but we'll have a wider berth here, so it won't be at that point. But if we extend the surface out, then you might run into issues when it comes to a point. As I stated earlier, one of the limitations on the fill surface is that if we want to use the end conditions, we need reference surfaces. In this case, I just have 2 simple extrusions. Now if I come in with the filled surface tool, you can see by default this just tries to connect them directly, and with that optimized surface turned on, you get this all coming to a point. So if I thicken this out, in this case I don't get the artifact on the end, but I get a pretty weird surface as a result. And if we do look at the face curves again, you see this all coming to a point, which is not what we want. Typically I just turn the optimize off. In certain cases this can produce weird geometry. You can see this is a little bit off of what we want. But if we change the end conditions, in this case I'm going to make these both curvature continuous. You can see in this case the optimized surface doesn't really change much. So we could have it on or off here, but typically, like I said, I'll leave it off. And here we get the nice smooth surface that we got from both of those other two operations. But in this case, when we go to thicken this, we get a nice clean surface without any defects in it. And if we try to come in and, for example, fillet this corner, we shouldn't have any issues. So fillets are another area that the singularities will mess with. The geometry will look fine, but if you try to create a fillet with that boundary surface thicken that we created earlier, you're probably going to run into issues. But that's how you generally use the boundary surface and fill surface tools. I'll be going into more details on the options for both the boundary and the fill in subsequent videos.